Welcome back to Cosmic Lab. Today, we're embarking on a mesmerizing journey to one of Earth's most enchanting natural wonders, the Aurora Borealis, also known as the Northern Lights. This isn't just a pretty glow in the sky, it's a stunning display where our planet dances with the forces of space. Imagine curtains of green, purple, and pink rippling across the night like a cosmic symphony. People from all over the world chase this phenomenon, and for good reason. It's a reminder of how connected Earth is to the vast universe beyond. Stick with me as we uncover the science, history, and best ways to witness it yourself. By the end, you'll be planning your own aurora hunt. Let's start with the basics. What exactly causes the Northern Lights? It all begins with the Sun, our closest star, about 150 million kilometers away. The Sun constantly blasts out a stream of charged particles called the solar wind. Think of it as a river of electrons and protons racing through space at speeds up to 800 kilometers per second. When this wind reaches Earth, it slams into our planet's magnetic field, which acts like an invisible shield. Most particles bounce off, but some get funneled toward the poles along magnetic lines. There, they collide with gases in our atmosphere, oxygen and nitrogen, exciting the atoms and making them release energy as light. Oxygen gives those iconic green and red hues, while nitrogen adds blues and purples. It's like nature's own neon sign, powered by solar storms. But why only at the poles? Earth's magnetic field is strongest near the north and south poles, creating what's called the auroral ovals, donut-shaped zones around each pole where the lights appear most often. The northern lights shimmer in the Arctic Circle, visible from places like Norway, Iceland, Alaska, and northern Canada. In the south, it's the Aurora Australis over Antarctica, Australia, and New Zealand. These displays can stretch hundreds of kilometers wide and last from minutes to hours, especially during solar maximum, a peak in the Sun's 11-year activity cycle. Right now, we're in one, so aurora sightings are more frequent and intense than usual. Imagine standing under a sky alive with swirling colors, feeling the chill air as the lights pulse like a heartbeat from space. Now, let's dive into the history and myths that make the aurora so captivating. Indigenous peoples have woven stories around it for centuries. The Inuit of North America believed the lights were spirits of ancestors playing a game with a walrus skull. In Norse mythology, they were reflections from the shields of Valkyries guiding warriors to Valhalla. Even ancient Chinese texts describe them as dragons battling in the heavens. Scientifically, the first real explanations came in the 1700s from explorers like Captain James Cook, who noted the southern lights. But it wasn't until the 20th century, with space missions, that we truly understood the solar connection. Satellites like NASA's Themis have mapped how solar flares, massive explosions on the Sun, trigger stronger auroras days later. These events can disrupt satellites and power grids, like the 1989 Quebec blackout caused by a geomagnetic storm. Yet, they're also beautiful harbingers of space weather. What makes the aurora even more thrilling is how accessible it is today. You don't need to be an astronaut. Apps like Aurora Forecast use real-time data from satellites to predict sightings. Head to dark sky spots away from city lights, ideally between September and March in the north, when nights are longest. Pro tip: look for clear skies during new moons for the best views. Some lucky folks have even seen faint auroras from lower latitudes during big storms, as far south as Mexico or Florida. And if you can't travel, live cams from places like Tromsø, Norway, stream the lights online. Photographers capture them with long exposures, turning fleeting dances into timeless art. But the aurora isn't unique to Earth, similar lights glow on other planets. Jupiter's massive magnetic field creates auroras brighter than ours, visible in ultraviolet from telescopes. Saturn and Uranus have them too, fueled by their own solar wind interactions. This shows auroras are a universal phenomenon, linking our world to the broader solar system. As we explore further, who knows what alien light shows we'll discover on exoplanets. The northern lights are more than a spectacle. They're Earth's way of showing us the invisible forces that protect and connect us to space. If this inspired you, imagine chasing them yourself someday. Which color in the aurora is your favorite, green, purple, or red? Drop it in the comments. If you loved this journey, smash that like button, subscribe to Cosmic Lab, and turn on notifications. We've got more Earth space wonders coming your way. Thanks for watching, bro. Keep looking up. Milky Way sparkles.